Welcome to Mindless Pursuits Beginning AI in Unreal Engine 4.10. This is part of the Common Concepts in Gaming series. My name is Keith, and I'll be your instructor. Topics I'm covering in this tutorial: I'll show you how to create a blackboard and a behavior tree, how to add the basic AI controller to an actor, adding a nav mesh to a level so you can have your character or your enemies or your allies move around. I'll show you how to create and add navigation or patrol points, take your own nomenclature. I'll show you different behaviors, so if they see you, if they detect you, we'll show you how to set them up to chase you. I'll show you how to have them attack, patrol, and run away. I'll show you how to expand your AI senses so that you can react to sound or smell or other things. Show you how you can set your AI up to make better decisions. And then I'll touch briefly on group behaviors. As for me, I'm a software developer of over 35 years experience. I was a kindergarten through 8th grade teacher. I love video games. I believe in sharing the learning process with you, and I'm never going to claim to be an expert at Unreal Engine. It is constantly evolving, and there's always more to learn and better ways to do things. I'll try to answer questions as best as I can when I can. And I'm open to your constructive feedback, and I encourage you to experiment. My approach may not always be the best one for what you're trying to do. And if you find a better way, feel free to share it. So what is artificial intelligence? Well, here's my definition for us. Artificial intelligence, or AI, is a coded system that allows a non-player actor to display thoughtful behavior similar to a living creature. This creates a better feeling of immersion into a game for the persons playing it. In other words, if you just have, let's say, a spider in a role-playing game, and you have that spider sent to randomly bounce around or just stand still, or it doesn't do things a spider does, it's not going to be very engaging for you as a player. It's not going to give you a sense that you're in that world. It's going to draw you out of it and break your suspension of disbelief. Whereas if you set up artificial intelligence for it, that creates behavior similar to a spider, so it knows how to move around a room, maybe knows how to climb walls, and knows how to spin a web, it knows when to attack a player, or if it's hurt, to run away. That's going to make it seem much more real to you, and it's going to be much more engaging for you as a game player, and that's what we want to see. So getting started, I'm going to show you what we're going to begin with, and then we'll build on it from there. So let's switch over to the Unreal Editor. So here's our starting point. I've taken the standard top-down game template, and I've made some modifications. So, for instance, in the normal top-down version, you'll click to move your character around. I've changed that so I can actually use the keys. I have made another change in that I have added this set of stairs to an elevated platform so we can show how the AI can move up and down and around. But otherwise, it's the same thing. If we go into our enemies folder, I have made a clone of the character blueprint. Which is blueprint here. So I've made a clone of this, and I'm just calling it the enemy human. And then I made material instances off of the base material so that he would be red. Otherwise, everything is the same as the normal character at the moment. If we press play, we'll see that we spawn down here. We're pretty high up because I moved the camera out far enough to be able to see things. We can move around. If you were doing the point and click, it didn't want to go up very well, but doing the normal walking, it does. This is actually a set of BSPs, but for the sake of this tutorial, I'm not concerned about a performance impact by using BSPs. And again, if we click, it doesn't actually do anything. It's all keyboard controls. So with that said, that's our starting point, and let's go into our first topic. Creating a blackboard and behavior tree supporting knowledge and decision making in AI. So, what is a blackboard? Simply put, a blackboard is a storage place that supports the AI through a behavior tree by storing data in a key-based manner. So, in other words, if you think of it kind of like a filing cabinet, you have a file folder within the filing cabinet. The filing cabinet would be the blackboard. You have a file folder that has a label on it, which is the key. meaning what you expect to find in that folder, hopefully descriptive to what's going to be in that folder. And then inside the folder you have data. So the blackboard replicates this. Once you create a blackboard, you create keys that are tied to that blackboard, and then you can associate data with those keys at runtime. So then what is a behavior tree? Well, a behavior tree is a prioritized hierarchical set of actions and selectors that tell the AI controller what behaviors to display. So based upon data in the blackboard, based upon events that happen that the AI controller relates to the behavior tree goes through prioritization and says, okay, based upon what I know, based upon what my intelligence behaviors are, I'm going to choose one based upon a given selector related to the information that's been given to me. So for instance, if no data is coming in, the priority is probably set to an idle action. So the enemy, the ally, whatever, is just doing idle behaviors. It might be wandering around. It might just be sitting, pacing back and forth. It might be patrolling, whatever the idle behavior is. But then, if the AI controller sends a message saying, hey, you know what? We've detected someone through our sensing. We're going to tell you what that something is. And now you can decide to take action, depending upon other items of information that might be stored in the behavior tree or passed through the enemy character or actor. You might decide to do a chase or an attack. And those are determined by selectors within the behavior tree. Now, we're not going to build our behavior tree yet. We're going to create the blueprints for the blackboard and the behavior tree. Then I'm going to show you how to tie in the AI controller, and then we'll come back and we'll start pulling all this together. So here we are back in the Unreal Editor, and you can see we have our enemy blueprint here. Now we're going to very quickly add our blackboard and our behavior tree. We'll start by right-clicking. And if we go into artificial intelligence down here, you can see we have a blackboard. We're just going to call that enemy human blackboard. Nothing terribly exciting. I'll show you what that looks like quick if you open it up. Again, you'll have keys, and then you'll have details related to those keys. We'll come back and explore that shortly. We go back, we right-click, we go down to Artificial Intelligence again, and we choose Behavior Tree. We will call this one Enemy Human Behaviors. If you're wondering why I'm specifying human, it's because I'm probably going to add a non-human entity at some point just to show how you can do things differently between the two. If we open Enemy Human Behaviors, you'll see we have the root, and it's already found our Enemy Human blackboard. And I'll say that that's not super intelligence, it's just that it's the only blackboard there in that folder, and it looks and it finds it and it goes, hey, I think this is it. So if we save this, you can then switch between the blackboard and the behavior tree, and we'll be doing that as we build stuff out. Now, let's take a second and talk about AI controllers. Now let's attach our AI to our actor, our enemy actor, by using an AI controller. So what's the difference between a standard controller and an AI controller? Well, of course, standard controllers are what we use to provide input from a player to their pawns, characters, etc., usually through keyboards or gamepads or something else. And we can define logic there. Of course, you can always define your logic in the character, but generally it's better practice to put it into the controller. And then, of course, controllers possess pawns. Well, the AI controllers are no different. AI controllers also possess pawns, and the difference is they receive their input from the system. So they're receiving their input from the AI and whatever the other elements of the system are telling them. And of course, AI controllers will use blackboards and behavior trees to define how the AI works and how they'll guide the pawn that they're currently possessing. So why don't we quickly add an AI controller, and then we'll move on to the next step. So we're back in the Unreal Editor, and of course we still have our enemy character, our behavior tree, and our blackboard. We're going to right-click. We need to go to the blueprint class up here. Under All Classes, we are going to find the AI controller. So find that, and we will click on it. We'll make this the enemy human AI controller. And of course, if you open it up, you'll see that there's really nothing to it yet. There's nothing going on. We haven't assigned any logic to it. We haven't attached any blackboards or anything to it. But we do have some components already. So, transform component, which doesn't do much. It's a fairly standard one. The path following, which is what we'll use with the nav mesh to move around the playing level. And then, of course, an actions component. So, once we have that created, we can go into our enemy human character. And on the right side, you'll find AI controller class. And we're actually going to change this from the generic AI controller to be our enemy human AI controller. And we can compile that, and we can save that. And now we have attached the AI to our character. Now in our next step, we're going to lay down a nav mesh, and then we'll start showing how our character can move and beginning our logic for interaction with players. So now let's look at adding our nav mesh to a level. A nav mesh is a way of creating a structure, or maybe not a structure, but a map, where an AI character can move around in a level. So now we're back in our Unreal Editor, and I want to show you something. We are using this top-down default, where I added in the BSPs for the little stairs and structure here, but other than that, I haven't really added anything else to the level. And if we collapse some of these folders, we will get down to one called Navigation. And inside Navigation, there is a Navigation Mesh Bounds volume. Well, that's actually what we do to set up our nav mesh. And if you were to click P right now, so click in the level and click P, you'll see areas turn green. And that's because that's where that navigation mesh already exists. And so anywhere in the screen, an AI character can attempt to navigate. Now note it does not go up the stairs, not to this raised area yet, because it's not large enough. You can see the boundaries of the volume, the navigation mesh volume right here. But that one already exists, and I want to show you how to add a new one, so we're going to go ahead and delete that one. Let's delete it out of there. Okay. We'll just do it the delete key way. There's also a recast nav mesh. We're going to go ahead and take that out of there at the moment as well, because we'll talk about those later. So you've got your level here. You don't have a nav mesh left, assuming you're making one from scratch, or you maybe using a different template that doesn't include one. And what you're going to do is first we need to zoom out a little bit because we want to be able to see our level. And then if you go to your volumes, you can scroll down and you can find nav mesh bounds. We're going to drag that out. And then we can always center it on the location by dragging it up or down. We'll do that a little bit. And then we're going to stretch it out so it fills our level. And I'm just going to go ahead and do this the manual way here. So we'll stretch that out. And I'm going to have to rotate this a little bit because I can't see the red one. There we go. We'll stretch that out again that way. And now you can see our nav mesh is back and it covers the entire level. And because our volume's a little higher than the other one was, it starts to go up the stairs a little bit. I'm going to turn this around and zoom back in a little bit. Now, of course, even with P pressed, if you were to click play, you're not going to see it in here. Your guy's not going to see it. But it's there. And if we want to extend it up on top of our raised platform here, we can do that. All we would do is grab this. We'll make it a little taller. Whoops, I think I grabbed the floor instead. Yes, I did. Let's undo that. Nav mesh. There we go. And we make that a little bigger. And you'll see that we now get a green box up here. There's one here because it's a little shorter, but there's no path connecting it, so it's less of a concern. If we want to make this a little taller, we still can. And you'll start seeing, green boxes pop up on more and more of the geometry as it fits, but the reality is we don't need it that tall. So we can peel it back down and just get it just tall enough that it goes there. And our characters, you'll see, won't navigate up on top of these unless we create a means for it to do so. So we won't worry about that, but we want to make certain we have our stairs and stuff at least slightly connected. We might have to make some changes here. And we'll save this out. As I said, we'll talk about the recast ones later. We can drag this back into our navigation folder, keep it nice and clean. And so now that we've got all of our main parts in place for our AI, we've got our blackboard, we have our behavior tree, we have our AI controller which is connected to our character, and now we have a nav mesh for them to be able to move around the level. Let's start binding these elements together. Let's connect them up to actually have our enemy character do something. So for our first behavior, let's create a basic view response where the enemy is going to just start chasing you around the moment they see you. So we're at the point where we have to start connecting everything up, because otherwise our character doesn't really do anything. So let's begin wiring everything together. And to start with, we're going to go into our controller, which of course is our AI controller controlling our enemy human. We'll double click that. And then right now it's a data only blueprint, so we have to make it a full blueprint. And inside of there, we aren't actually going to use the event tick, so we'll just get rid of that to keep it nice and clean. And off our begin play, we're going to tell it to run our behavior tree, which is how we wire it up to our behavior tree and get it going. And our asset, of course, is our enemy human behaviors. And this will just automatically start running that behavior tree at startup. But the behavior tree doesn't have anything to act on at the moment. We have no keys, we have no data coming into it, none of it. So what we have to do is we have to add a component that is going to sense our player character or sense other pawns, and that's called the pawn sensing component. And so if we go to add component, we do a search for pawn, you'll see pawn sensing. There's also a noise emitter, which we'll come back to in a little bit. And there's a floating pawn movement that we're not going to be using in this particular session, but we'll talk about in advanced AI. So choose the pawn sensing, and you'll see that has been added there. If you click on it, you can see that there are different variables for it, thresholds for hearing and seeing and other things. Only sense players, which is something you might turn off in other games if you wanted to detect other AI characters or things like that. But we're just going to leave it all alone. Peripheral vision angle, it's a 90-degree cone out from the start. You could always increase the size if you wanted to have it be able to see all the way around it. We're going to leave it at 90 at the moment so we can talk about the issues there. Or if you want to call it issues. So now we have that, we can compile it. And you're going to go to this on C pawn. We're not going to talk about noise at the moment. We'll come back to that. But on C pawn, you're going to click that, and it'll add a node for on C pawn and pawn sensing. And here we're going to start to add data to our blackboard so that the character can use it. So the first thing is this pawn that it's sensing here is going to be the player character, because if you remember in pawn sensing, we said only sense players. We only have the one player. So if we go ahead and we drag off of this, we know it's going to be our top-down player. But to make certain, we're going to cast to that. And then we actually need to get a reference to our blackboard. So we need a reference to self, and then our attached blackboard. So we'll get our blackboard. And then last but not least, we need to know the key name that's going to be stored in the blackboard. So this won't create it. We still have to create the key in the blackboard, but this will know to look for that key in the blackboard and then assign the value. So to do that, we're going to make a literal name. And that name in this case is just going to be player, since we're looking at our player. And now we need to put all this into the blackboard. And the way we're going to do that is through set value as object. We have to turn off context sensitivity for that. And go down, you can find set value as object. And then the blackboard is actually the object where we're setting the value. So you're going to connect the blackboard to the target. Our literal name of the value of player is actually going to be the key name that we're assigning our value to. And then last but not least, the object reference for our character is the value we're putting in there. So we can compile that and save. And that's all set. And now we have to go to our behavior tree in Blackboard. So we'll go back over here. And remember, if you open the behavior tree, you can switch right over to the Blackboard and keep them connected. We're going to create a new key. And that key is going to be an object type. And we're going to call it player, just like we did in our name there. And our player is going to be an object. And we can change the key type to be an actor. So we're storing a specific value to an actor. We'll talk about instance synced when we get into advanced AI, but for now we'll leave that blank. You can always put in a description if you want. So we'll say this is the player currently targeted. And that way we have a value for it if we want. So there's our key. If we flip back over to the behavior tree now, we have our root. And of course, all of our actions are going to come off of this root. And in this case, we're going to create a simple chase behavior. So if you go to where it's yellow and you drag down, you'll see we got a nice little arrow here. Let go. And you choose from one of these things. And we're going to choose a sequence. The sequence is a set of steps that it takes when it wants to do something. So in this case, our sequence is going to be renamed. We're going to call that chase player. You'll see it changes the name here. And the question is, how does it know to chase the player? Let's say you have a whole bunch of different actions set up off of here. How does it know to chase them? Well, two reasons. First, whatever comes to the left in the hierarchy is considered a higher priority than the right, but you can also add what's called a selector to it. And so we'll do that. We'll right-click and add a decorator. And the decorator in this case is kind of a selector, which is a blackboard. So we're going to set a blackboard base condition where it does it. And in this case, we click on that, so we're highlighting the blue part. You can see we're looking for a result change. When that result changes, it's going to abort. It can abort itself, lower priority tasks, or everything. We're just going to abort the lower priority tasks, which again would be anything to the right that it might be doing, like idle functions, or maybe you have it set to attack other characters as well, but you have a means of detecting that they're a lower priority character, they're not as much of a threat. You can put all that in there. What we're doing is we're checking to see if the blackboard key is set. So in this case, our player key, if our player key has been set, then we are going to take this action, which is to chase our player. We can save that so far. And then what do we do when we chase our player? We're going to need to move to where our player is at. So we can drag this down again, and we'll choose a task. And you have lots of tasks you can choose from, but in this case, we are going to move to, and that's going to move us to a location. And so with that selected, the key is going to choose to get the value for where it needs to move to. We're going to switch that to player, and that way it'll attempt to move to where our player is at. And it'll stop if they overlap, so if it actually catches us, it'll stop moving around. It'll start again when we move. So we'll click on save, and that's it. That should be our basic setup. So if we go back into our map here, so you can see we need to drag out an instance of our enemy. So we'll do that, and we'll put him over here so he can't see us right off the bat, because his cone of vision is going to extend out in a 90-degree angle from his front. So it's going to be straight out here. And that's going to lead to some interesting behaviors. So we click play. As you can see, he can't see us right now. If we were to come up here, now we're in his cone of vision. He can see us. He will happily chase us around. And right now he's as fast as we are, so we can catch up pretty easy. If we go up the stairs, he can follow us up the stairs because that green path was there. However, if we jump off, he has to go all the way back around, but he has nothing that tells him he can jump from that one green section down here because there's no connecting along this wall. So we're to escape. You can see he can go to this point, but then he can't jump off yet. He doesn't know how to jump off, and we'll come back and we'll talk about that. But he can connect and follow us around up here. Now, let's go back in here for a moment, and I want to show you something. Okay, so let's go here, we're around, and we can get this close, and he doesn't know we're here. And we're not exactly, we don't have a stealth mode defined or anything. It's just, we're not in his cone of vision, because again, his cone of vision is 90 degrees. That goes off at, an angle like this. So we can actually get pretty far up there. We can get right next to him, and he still doesn't sense us. We can get up there, now he finally senses us. So, if you're going to have a real AI, you're going to give him better peripheral vision than that. And so what you might end up doing is extending out the cone. So let's stop. Let's put our cone back here for a second. So what you might do is have it to where, let's say you have 180, so you've got it going straight out both sides. But you don't necessarily want him to detect when he's behind here. So if you did that, you might have, upon detecting it, what you're actually going to do is you're going to run an action that says, hey, let's do a ray trace from our character here, from our enemy character. Let's do a ray trace and see if we actually have a line of sight to the character. And of course we would have this in the way, so even though he'd be within that 120 degrees, he wouldn't see it, because he wouldn't be able to move through that. Okay, so that's a basic chase behavior, but of course, as you saw, he's as fast as our player is, so we need to slow him down just a little bit. So I have to remember for a second where that is. There we go. So max walk speed, we're going to actually change that. We're going to make him a little slower. We'll say 400. And we're not going to worry about the crouching because he's not going to crouch. So we change that, we save it, we play. We can go up here. Okay, he sees us now, but we can easily outstrip him if we need to. We can go up here, we can get far away. And right now he's going to keep following us because we have nothing whatsoever that tells him to stop following us. So even if we're way out of range, if we're out of sight for an extended period, all that stuff, he's still going to keep following us. He's going to find us no matter what. So right now, because we're moving faster than he is, in theory, we've outstripped him, but you see he just keeps adapting and will catch up with us. So let's change that. Let's make it to where if he doesn't see us for a while, if we get too far out of range, he stops. Okay, so first let's make it to where if he catches us, he stops. He's caught us, the game of tag is over, and he's going to not chase us unless we do something to where he starts chasing us again. So to do that, we are going to want to go into our enemy human behaviors again, and we have our nice set of tasks here. And move player will keep occurring until he actually catches us. So for this first example, let's just leave that as it is. Now if he catches us, meaning he's gotten to where we are, we're overlapped, then we're going to make him wait for a little bit so we can drag down and get a new task, and this task will be wait. So we have that. We're not going to make him wait too long. We'll say 2 seconds maybe 3. Or I can set it random, so you can say, hey, he's going to wait for however long after he catches us, but we'll just stick with a straight 2 seconds. And you'll notice that now that we've added another node, we start having these numbers pop up, and that shows the order in which they're executed in this sequence. So move to will happen until move to stops being triggered, then wait will happen. And now we're actually going to have a new one. But we don't have a task that is stop chasing us. So we're going to have to create one. If you go up to your menu bar here, we have a task generator or new decorator, whatever. And we can click on new task. And it creates this BT task blueprint base new. And here's where we're going to define what happens in a given task that we create ourselves. We can save this for a minute. I'm going to close this out because let's give this a better name. Now you can see it's in our folder, our enemies folder. So if we double click on it, well, not double click on it, but click on it to change the name, we will rename it to something like Chase Reset. Oops. And then we can open it back up and we'll make it a full blueprint again. This node name is what's going to show up in our behavior tree when we add it. So let's go ahead and call this reset chase task. We'll compile and save that again. And then what we're going to want to do is we're going to want to receive the key that we're going to use to reset the chase. Now we could manually define the key in here, player and so on, but we'll make this flexible so that as we grow our behavior tree, we can always use this again for other things if we want to change the name. So let's go ahead and start with, we need to add an event, and that event in this case is to receive a notice to execute. So event receive execute, and this is what triggers a task. So this will come from the behavior tree and it will trigger this task name. Now what we're actually going to do is we're going to reset our player key in the blackboard. So we want to set our blackboard object again. Whoops. So set blackboard value as object. In this case, we want to let the task tell us what is going to be reset. And to do that, if we go look over here, for instance, we have move to player. We tell it here the key is player and the node and all that. We can do that in here by adding variables. So we're going to add a variable. The first one is going to be key, so the key we're going to reset. And this has a special type, which is this is a blackboard key selector. You can see that here, blackboard key selector. And we want that to be editable. That way it will actually show up in the taskbar over here. Okay, and next we want to add a variable which is our player, because of course we're resetting our player value. And that will also be editable, but it's going to be a type of object. Or in this case, a type of actor. So we'll just get a reference to an actor. And then we can drag both of these down here. And get them both. And do the assign. Compile, and that'll get rid of that error. And then of course we want to finish executing this task. Once we finish executing, we'll tell it that it's successful. Now you can do, of course, error checking, make certain you set the value, that the value is valid, and so on. But right now we're going to be setting a blank value anyway, so it's not going to matter. So when you save that, and then we can go into our enemy human behaviors again. And if we drag down to the right, we can always add that task, or we just see it right up here, chase reset task. So it's there. And if we want, we can give it a better name. So we can call it reset the player scene. And of course, you might not want to have a whole lot of long names cluttering up, so we can always just say reset player scene or reset player. We'll leave it as reset player scene. And our key that we're acting off of is the player character, and we're setting it to none, right? Because again here, our input variables were what key are we going to set a value to, and it's going to be an actor type called player. And so here, the key is the player key, and then the value is going to be none. Okay. we're going to save all here. Now, if we go back to our map, and we run around, and we allow him to see us, he's going to start chasing us. Of course, we're slightly faster than he is, so he will keep chasing us at the moment, unless we let him catch us. If we let him catch us, he stops, because he's already caught us. And he'll stay that way, and he doesn't go back to a start or anything, because we haven't told him to do that or how to do that. But he stopped. He's caught his goal, and he's not going anymore. If we go back up here, he sees us again. He'll chase around to let him catch us, and then he stops again. So now let's add the behavior so that he gives up if he doesn't see us for a certain amount of time. So here's our problem, which is in order to get them to lose the line of sight, meaning, if the enemy is here and you manage to run over here and they lose sight of you, therefore they stop chasing you, or if you just get far enough away, they stop chasing you. With the pawn sensing component, you're going to have to add a lot of logic. You're going to have to add a ray trace in. You're going to have to do some checks on distance. And then you're going to have to create new tasks to add to your tree to accommodate that. Well, there's actually a different way to approach all this. And it came with version 4.8, and it's called the AI perception component. And the pawn sensing component that we use so far is actually going to be deprecated. It's going to be removed from service in favor of the AI perception component. Now, the pawn sensing component is pretty straightforward, but the AI perception component has more flexibility and more power in the long run, but it's a little more confusing. It's a little steeper learning curve to get into. But in order to achieve what we want to achieve, it's easier to switch to the AI perception component, and that way not only are we set for the way Unreal Engine is going to behave moving forward, we don't have to create a lot of extra work for ourselves. So I will show you how we implement that. And the first thing we have to do is we go to our AI controller, and we're not going to use this pawn sensing controller anymore. So we are going to remove that. We're going to add a component which is AI perception. As you'll see, AI perception also has hearing range and all that, but all this is deprecated. This isn't actually being used anymore. And I keep wondering why in 4.9 and 4.10 they didn't just remove access to it. But here's where you're going to set up your different senses, and including a dominant sense. So right now we're just dealing with being able to see something. So we would add a sense config, and that sense config is for sight. Now you can see you can have it sense when it's damaged, you can have it do hearing, you can have it predict what's going to happen, you can have sight if someone's on the same team or if it's been touched, etc., etc. We are going to stick with sight config, and if you open that up in the sense, then you can actually change things. So you can say, within what radius will we actually see something that can be sensed, and when will we lose sight of it as far as distance, and then of course there's line of sight as well. So for our sake, we're going to crank this way down. We're going to make this like 500 for our sight radius. So when we're within 500, if we're in the cone of sight, we'll see it. And if we get more than, 1,000 away, then it has this thing called detect by affiliation. Now in C++, you can actually make this work to where you can define enemies and neutrals and friendlies and all that. It doesn't seem to work yet in blueprints, at least I haven't been able to make it work as of recording this video. And if you say detect enemies, it doesn't actually know that your player character is an enemy. So it's easier just to click those and have it detect everything. I'm hoping that they'll clarify that or fix that soon for blueprints. And then of course, you can put the success range, max age, so if you have a stimulus be forgotten, you can do that. So you can set it to 20 seconds or whatever. And if it starts enabled, which it does. Down here you can always say if you have multiple senses done, you can say that the sight is the dominant one. Well, it's the only one we have implemented, so it's not going to matter for us one way or the other, but we can do that. And what you'll see is that we now have on perception updated. So we don't use this pawn sensing event anymore. It doesn't exist. So instead, we are going to have to make a change here to to our controller, and we're going to implement a new thing. We're actually going to just get rid of that because we're still going to use this. We'll just move it down and out of the way for the moment. Click on our AR perception again. We're going to on perception updated. And our on perception updated, we can try and make this so it's kind of neat. Move it back up here. And what happens is it will pass us an array of all the actors that have been perceived. Now there's a way you register actors to be perceived by this perception component, and we'll come back to that in a moment. But what we're going to do is we're going to get our array of actors that have been perceived, and then we are going to run them through for each loop. At the moment, because we'll only have our player character, that's really the only one that's going to be received. But I would say run through the loop anyway, and that way if you add things in the future, you can just split off based upon the type of perceived actor, because you may have multiple players. You may want to include other AI types that you're going to detect and take action upon. When you want to do that, you're going to want to loop through them all. Then you're going to need to get the perception. So get actor's perception, and that gives you the perception that the AI has for that particular thing. So we'll drag down the AI perception component because that's what we're querying, and we're going to see how it perceives each actor that it pulls up in this loop. So we pull up the loop, we grab an actor, and then we see how this AI perceives that actor. If you want to get more information there, what we'll do is we will actually break this. Whoops. We'll actually break this out. So we can break the actor perception blueprint info like this. And we're going to base what we do off of that. And we're still going to come back to this, so I'm going to keep moving this over for now. So we've got our actor perception blueprint info. And from that, we're going to get the stimulus for the current actor. So the current result being brought back. So we'll get the current array item, which in this case would be the first perception for that actor. And we're going to break that out as well. So we're breaking the AI stimulus because that's the structure that's being returned. Keep moving this. Move that way over there. And as you can see, there are a lot of different things to sense upon, but what we're going to actually do is successfully sensed. So we want to know if we're sensing something or not. And so we're going to go ahead and add a branch based upon that. And we'll connect that up. So if we actually perceive something, then we want to take an action. And we're going to want to take an action based upon the target, which in this case should be a reference to our player character. We'll move this over and up here. And we are going to cast this just as we did before. Whoops, back. That's the reason why I kept all this. We are going to cast this to our top-down character. So we'll connect that up. So if it's true, we'll cast and we'll go. I'm going to try and be neat with these things. So we'll go like this. We'll compile it. And in theory, if it has perceived our character, if it has sensed them, it will do the same thing pawn sensing did. It'll set the value, and then we'll be able to take off. So let's see what happens. We click play. We go running. And it senses us. Of course, it ran into us, so. But it's us now. It has stopped doing anything. It doesn't know what to do anymore. Let's try that again. We'll do this. Off we go, off we go. And of course, just like before, it keeps sensing us, it keeps running after us, If it runs into us, it will stop. And that will be that. Get back in its line of sight. Away we go. Hits us again, it stops. So nothing has actually changed there, other than we've changed this code. But now we can take a different action, because if it doesn't sense us anymore, we can change this. And so what we're going to do is, if it's false, we're going to do another set value as object. Okay. And we're going to go to the same blackboard. And we're going to use the same little name. But we're not going to actually set an object value. That'll set this back to none. And therefore, we should lose our setting that we're relying upon here. And it should stop working. But you're going to see that that doesn't actually work right. So we'll go like this. It sees us. Now in theory, we are going to run way out of range. We're going to go out of the line of sight. But as you can see, he's still following us. So even though by not sensing it, we have reset that blackboard value, he's still going to follow us until he hits us. And of course, you see that even though he caught us, and he's only supposed to wait 2 seconds before he sees if he can still see us, he doesn't react to us unless we go out of his sight and then back in. So that's an issue we have to correct as well. So, if we go back to our AI controller, this is actually all good. What we have to change now is we have to actually change our enemy human behaviors. So right now, we're being based upon this. And if we go into our player, it aborts all the lower priority. And one of the things we want to check is, of course, if the result changes, how about if we just abort ourselves? So, if the value changes and it's not valid anymore, you'd think that that would just kill us. So, we'll make that change quick. We'll go back in, we'll play, and we'll see what happens. Chases us around. We should be out of sight now, but nope, he is still following us. And I want to show you something else where we're doing this. Now, if you want to debug, if you want to see some cool information for your AI when you're going, let's stop this first. Go to Edit and find your editor preferences. And then you're going to click on Gameplay Debugger. And you want to turn on the behavior tree and the perception. You can save that out. And then click the Show button here. And you're going to go down to Developer and click AI Debug. Save it. And now if you press play and you hit the double quotes just to the left of the Enter key, you'll see all sorts of data come up related to your AI. You can see what the controller is for it, what behavior tree component it's running, and what its perception is. So if we move up, you can see the green radius around it. That's its sight. So if you go within that, you're going to be seen. If you are outside of the purple, then you shouldn't be seen. So if I go up here, I'm seen now. I get far enough away. And you see where that green ball goes? That means that's actually where it lost sight of me. So it lost sight of me, but it's still following me around because nothing has updated the move to component. It's still trying to use that move to component. And of course, if it gets close enough, it then sees me properly again. And you can turn off the different areas of this debug by using your numpad. So if I click 1, I turn that basic data off. 2 toggles the behavior tree and so on. If you're really want to get fancy, if you hit tab, you can then move the camera around as you need to without affecting what's going on. You can just see from different angles. Hit tab off again and it goes back. So, that change didn't solve our problem. But it's important because We still want to terminate this if our value changes and we aren't running it anymore. What we're going to do is we're going to add an actual selector. So this was a sequence, and we're going to add a selector based upon whether the value of player is set or not. So I'm going to drag this down, and we're going to add a selector. We're going to use this selector as the basis of action going forward. And this selector is going to be called React to Player. So if it senses a player, these are all the different ways it's going to react to a player. And of course, to know if it senses a player or not, we have to add a decorator to it, which is going to be the same blackboard type decorator. A result change, we don't do anything to ourselves, but we're going to alter what happens further down the selector chain. If it's set, and if the player is set, then it's going to run from left to right the items that are underneath the selector. So we can pull this down like this, and it will go ahead and run. So the idea being, it comes to the selector. If the player is set, then it will actually start pulling from left to right down here for actions. And of course, based upon what action it finds on here it can run, it'll go left to right. Otherwise, if the player is not set, the selector will not run anything below it. So let's go ahead and play again and see what happens. So we go up. It sees us. Run away. We got out of the line of sight and it stopped. We come back in the line of sight. It sees us again. Get far enough away and it stops. See us again. If we get far enough away, it stops sensing us. Line of sight. There we go. Whoop. And of course, now it touched me, so we're going to run around here for a second so I can show you something else. Okay. So it has now touched us, and after 2 seconds, it should pick back up and go for us again, right? That's what we want. We don't want it to just stand there after it's caught us, even if it can see it. Or, if it can see us, we want it to still go after us after 2 seconds. But no, we still have to run out of sight and then back in to get it to react. So let's stop. We will go back to our enemy human behaviors. And what we have is we have the move to that executes as long as it can see us. And if it hits us, then it does the wait for 2 seconds. And then it wants to reset player scene. Well, it can't see us anyway, so this actually has a negative effect. It doesn't do what we want. It breaks the behavior for perception. So what we're going to do is we're going to delete that. We'll save it. And now watch. We'll go up here. First again, we're going to prove that we can lose line of sight that way. He sees us. Let's let him touch us. We get a little bit ahead. 2 seconds later, you can see he picks up because we're still within his line of sight. Now, let's do this for a moment. Let's go here. If we get far enough out of range before the 2 seconds is up, which I apparently am not doing, then he doesn't pick us up until we're back within that line of sight. So there's our behavior that we wanted. We wanted to be able to have him detect us and chase us if we get detected. We want to be able to stop being chased if we go out of sight. And then if we are far enough away, to not pick up the chase again as well. Now, if you want to get more complex, you can start adding in prediction. For instance, we might want to have an AI that says, I saw them go around this corner, so even though I don't have line of sight, I want to keep chasing them. We'll talk about that when we get into the AI, or the advanced AI tutorial, which will come down the road. But for now, there's your basic chasing behavior. Now, let's explore our next behavior, which is going to be to have the enemy AI do some patrolling. Patrolling versus wandering. So patrolling, you're going to set up a predefined path of different navigation points that the AI is going to follow in a predetermined order. So it's always going to be the same path repeated. Now you could have variations of patrols based upon character type or time of day or other things, but it's still going to be a preset path and a preset order. Conversely, wandering may use preset navigation points, but it's going to be in a more random or less determined order. So your less determined might be that you want them to wander or randomly move between points within a certain area, but it's still random within that area. They're just wandering around. And less determined there again being those are points within a certain area, not necessarily the whole map. You may not want them to wander the whole map. You may just want them to wander a certain area. And of course, both of these approaches, whether it be patrolling or wandering, can make use of the same navigation or patrol points. So let's look at how we add navigation or patrol points to a level. Now you could drag what's called a target point onto the level. And a target point is a placeholder that's visible in the editor but not at runtime. So you can attach data to it, location information, whatever else. In our case, we're going to actually make a new blueprint for it. So we'll choose a blueprint, and the type for our blueprint is target point. We're going to call this a patrol point. Now you might just have navigation point as a different type, and make your patrol point a child class of navigation point. It's kind of up to you how you want to do it. Because we're only going to talk about patrolling and not wandering or anything on this particular video, we will stick with patrol point. You're going to want to open up your patrol point, and we only have to do one more thing to it, which is we will add a sphere collision. That way when our enemy runs into the patrol point, we know that he's actually hit it because he'll cause a collision. And if you wanted to go the extra step, you might add a name component to your patrol points to distinguish one type of patrol point from another, in case you're going to have, different variations of your patrols, and you don't want to necessarily create a whole bunch of different classes for it or something else. But we're just going to stick with patrol point for now. We'll save that. And then, of course, we have to have a way of storing our patrol points. And we're going to want to do that within the actual character, not within the controller. And it seems to be a little simpler there, less stuff floating around, but also for replication and other things. So, if we go to our enemy human character, we'll double click that and open it up. And we're going to add is some variables to hold our patrol point information. So first off, we want something that's going to hold our list of patrol points, because we could have more than one or two. And so we'll get that, and we'll make it a type of patrol point. So we'll store a reference to patrol point. It's actually going to be an array, in case we have more than one. We'll compile that. And then we're going to want to know what our current patrol point is. So we'll have a current patrol point, and that will not be an array. That will just be a single patrol point reference. We're going to want to know what patrol point number we're on, because we're going to want to increment our patrol points as we go along. And one thing you could do is within the patrol points themselves, if you wanted, you could actually have a variable that's next patrol point and point it to what the next patrol point is going to be from an object standpoint. I'm not going to be that complex. We're just going to have a number of patrol points in an array, and we're going to increment the number of the element in the array we're going to return to be our next patrol point. So we'll have current patrol point number. And if you want to see a different way of doing it, where you can have the next patrol points defined in the current patrol point, just let me know and I'll put that into the advanced tutorial when I get that recorded. But for our current patrol point, that's going to be an integer. That's going to be editable. And then our patrol point key name will be what we are calling our patrol point in the Blackboard. It will be a type of name, and it will be editable. We'll compile that so we can see it. And it's just going to be patrol point. So there's all of our variables to hold everything. Now, let's think through the logic here for a second. Let's go back to our map. And we are going to move up a little bit here. We're just going to set up some basic patrol points. So our first patrol point we will put here. And let's go ahead and create a folder to store these in. So while you've got this selected, add new folder. And we will call it patrol points. So we have our first patrol point. We'll drag up a second patrol point. We can put that underneath as well. Okay. And then a third patrol point, which we'll drag up underneath there. Come on. Right? And then last but not least, a fourth patrol point. We'll just have them go in a nice square around this particular one. Nothing terribly exciting. Okay. So there's our fourth patrol point. We'll save that. So he'll start here, he'll go up and around. Now we might want to actually move our character back, because otherwise he would start here, run back there, and go around, or something to that effect. So we'll just start with this. We'll save our map. Now let's go back into our human here, and let's think about our logic for this, which is we want to, at the start of his playing, we will have him start patrolling, and he'll just go around all the points in order. And each time he hits a point, he will check to see what the next point is and update his current patrol point to be the next point. So let's set that up. We will add an event for begin play. And first thing we're going to want to do is we're going to get all of our patrol points. Whoops. So get all actors of class. Choose patrol point. And again, if you were going to have multiple patrol paths and other stuff, you might want to get the class and then, sort out the ones that have a particular tag or name to them. You might choose to add an interface to the patrol point instead and get all actors with a certain interface. Again, we're just going to have one patrol point for this particular tutorial, so we're just going to have all actors of class patrol point picked up. And once we do that, we are going to set our array of patrol points with all the patrol points that we got back from that selector. We are going to want to get a patrol point, so we want to get the first patrol point, and to do that we will do a get on the array, and then we are going to want to set our current patrol point. So like this, and we're grabbing the first one if we want, but we're really going to start with the second one in our array because he's going to be standing by the first one. So we will pull this up and we'll do a get. So our current patrol point number that we start with is 0, and we're actually going to want to start with a 1. So we're going to plug that in there, and for our default value we're going to start with 1 because we're not going to start with the one that would be an index 0, which is the first one we put down there. It's going to be the first one after that. Always remember, arrays start with an index of 0. So we've got that, and we want to make certain that our patrol points and stuff are valid. We are in the begin play section, so things might not have all been instantiated yet, and we want to make certain that they're valid before we use them. So we're going to pull up an is valid here, and we are going to check to make certain that this patrol point is in fact valid. And then we're going to want to get the blackboard. We're going to want to make certain our blackboard is ready and valid as well, because we're going to store this patrol point in the blackboard. We're going to go ahead and do a set value as object. And the value we're ultimately going to set is going to be that current patrol point. So we'll drag that over there. Keep this neat. We need to get a reference to our blackboard. So self, and then get blackboard. We're going to want to plug that into here because we're checking to see if that's valid. And we're going to plug it into here as well because that's where we're going to make our change. And then we can grab our patrol point key name. And we plug that up here. And so again, let's follow back. At the start of play, when this one is created, we get all the patrol points. And we're going to set ourselves to the second patrol point in the array, which we set here to be our current patrol point. We make certain that patrol point is valid. We don't want to keep going if it isn't valid yet, if it hasn't been instantiated. We make certain our blackboard is valid, and then we assign the current patrol point to our blackboard object. Of course, we haven't created that key in our blackboard yet, so let's go do that. Go to enemy human behaviors up here and go to the blackboard. We'll create a new key, which is an object called patrol point. And its key type is object. And we're going to go ahead and make it a patrol point. So we can save that. Go back to our enemy human. We'll compile this and save that, make certain that's okay. And then we're going to follow a similar path for when they actually get to the patrol point. So as they move around, go back to our map for a second, as he moves from here and gets to this one, he's going to overlap this patrol point. And we want to know that he's overlapped it so we can tell the character to go grab the next patrol point. Go back to our enemy human event graph. Let's add an event for actor. Whoops, I'm probably doing that wrong. Actor. Actor over. What am I missing? On actor overlap. Actor begin overlap. There we go. Actor begin overlap. Brain went south there for a second. Here, we'll give ourselves plenty of space here. And what we're going to want to do here is we want to check and see if the patrol point we've just overlapped is the one we were expecting to go to. So let's grab our current patrol point. And then we can do an object equal. So we see if it's the same one. If it is, the same one, then we're going to want to go to the next one. We're going to want to set up the next patrol point. So our current patrol point number needs to be incremented by 1. So we can do that. And then we're going to set our current patrol number to be the new value. And of course you could do the plus here, the increment that way. Here, let me show you. You can go like this, increment int, and that would be just as valid. You can put this up here. But for the sake of the tutorial, I want to keep everything as clear as possible. So we're going to do an integer plus an integer, so integer plus 1. That's what's going to be set as our new patrol number. So if our patrol number was currently 1, it'll now become 2. We want to know how many patrol points we have, because if we're at the end of our number of patrol points, we're going to have to set it back to the beginning. So we'll get our patrol points, and we're going to get the length, which will tell us the number of patrol points. And so if our length is equal to our current patrol point number, then we actually need to reset our patrol point number. Now you could also have done this here, done the check before you set this, and just look for length minus 1. But again, I'm trying to be very, very clear about what I'm doing here. So we need a branch up here. And again, if that's true, if it is equal to it, then we are going to set our patrol point back to 0, which will take us back to the first patrol point in the list. And if it's false, then we just want to set our current patrol point. So, oops. There we go. Set our current patrol point. Come on, connect. There we go. So if it's false, we're still going to connect up, but we're going to bypass resetting this point number. So we'll go like this. Go like that to keep it nice and neat. We need to get our patrol points. We're going to get the current patrol point number. So we get the correct index here. And that's what we're going to use to set our patrol point. So if it was equal to the length, therefore we have to start over. We set it to 0, which will get us the first one. Otherwise, it'll give us whatever the current patrol point number is out of the list. And of course, we can always check to make certain it's valid again. And for the most part, this is going to end up being the same as it was up here. So if we do this, we can go like this and duplicate it, drag it down, and we'll save ourselves some typing. So where I had that one, we can actually move that out, connect that. So again, we're checking for our validity to our current patrol point. We're checking to make certain the blackboard is valid, and then moving on. So we'll compile and save that. Now we have one last thing we have to do, which is we have to update our blackboard. So we've got our patrol points created, we've got them on the map, we've now told the enemy human blueprint how to tell what patrol point it needs to move to, what to start with and what to move to after it gets there. We have the blackboard storing the patrol point key. Now we actually have to go into our behavior tree and edit it. So right now we're calling straight into this blackboard base condition, but we have to go up one more level because we only go in here if the player is set. So what we want to do is we want to change. We're going to add a new generic selector. Not going to bother giving that a name. It'll go there, but, slide this up a little more, but if there is nothing set, then we need to have it do something else. So we'll do a sequence. We're going to call this sequence patrol. Okay. And all of our patrol sequence is going to do is it's going to move to the currently set patrol point. So we can give it a move to task. And our move to task, we are going to not worry about stop on overlap because we'll just keep going. We are going to look at the patrol point, and because it might be a little loose for moving around the patrol points, we will set this to 20 for the acceptable radius for knowing if we made it there or not. So with all that set, let's go in and see what happens. Whoops. So now we'll play. You can see he's going. Of course, it got them out of order. So we might want to do something to change that. So up here it just got them kind of willy-nilly, not necessarily in the order we put them in. So we may need to change that somehow to change the sort. That's under enemy human. So when we first get our patrol points, we could go through and resort all of these to get them to be how we want. Another way you can actually do that, which I will show you, is let's remove these ones. Edit, delete. There we go. So you can go like this. And if you just sit here and duplicate these, It actually puts them in the correct order. It's kind of a cheat. Okay. Save, play. And now you'll see he actually goes around them all in that order. And I admit, I only cheated right there because you can write your own sort routines. There's different ways that you might want to do it for speed, depending upon the volume of patrol points you're going to have or how you're going to have your patrol points set up. So I didn't want to get into that in this video. Just wanted to show you quickly how you could change that. Now, if we go over, you'll see us. And when he sees us, he starts pursuing us, which is what we would expect. The moment he loses sight of us, he goes back to his patrol. Again, he can pursue us. If he touches us, he's going to forget about us for a bit. We go out of his sight line, and he goes back to patrolling. And then finally, he sees us. We'll run over here again, let him touch us. He's going to wait 2 seconds. He still sees us, so he's going to pursue us. So there you have it. There's the basic patrolling routine. It still keeps our logic for chasing. It sends him back to the patrol if he loses sight of us. And that's pretty cool. And again, we're using the combination of the AI perception system and some new class we set up for patrol points. But everything, all the logic is contained in our blackboard. So all the real heavy lifting, as it were, for the AI is occurring here. Now let's shift over to talk about attacking behaviors. For the purpose of this tutorial, we're just going to show how a melee attack might work. So that's chasing our player, it's actually caught up to him, and it has the chance to do a melee attack, whether it be a claw or with a sword or something else. But it's right there with the player. Now we'll show you how to do that in this tutorial, and then I will give you some tips for how you can do it for shooting from a distance or bow attacks or something like that from a distance. But I'm going to wait to cover that in detail until the advanced AI tutorial. So let's take a look at melee attacking. To get started in adding a melee attacking behavior, one of the first things we're going to do is define just what happens when our player is attacked. Now, we're not going to go whole hog and set up a health system and a number of attacks for the AI or anything. We just want to have it to where we get close enough and the attack behavior is engaged that we can see that something has happened. So what we're going to do is we are going to add an event to our actual human character, our top-down character blueprint. And we're going to add a custom event that we will call attacked. So this is when the player is being attacked. What we're going to do is just going to be very straightforward. We are going to get the mesh, and we are going to set the material on the mesh and have it flash. So we'll set a material once, and then we'll have a delay, and then we'll set the material again. Back to what it was originally. So we can implement that very quickly. So our material we're going to change to, when we blink, we'll just make it the same as enemy body, so our character will flash red. And then we'll go back to our normal body. So compile and we'll save that. And then we don't have any such thing as an attack player task. So we need to create one of those. So we're going to go up to new task again. And just like we did before, we will save this off and go to our enemies folder and find that one and rename it. And we'll call it the attack player task. Okay, go back into it, open the full blueprint, and we need to add one variable, which we'll call target player. Make that editable, and its type is going to be a blackboard key. Just compile and save that. And then for our event, we're going to receive the execute. So we can kick off that event. We are going to get the target player that is passed in. And so we'll get the value of it, which will return the object for us. We're going to turn that as an actor. Then we'll make certain that's actually valid before we try and do anything with it. Assuming it's valid, we're going to want to cast it to our top-down character. And then we will call a function that we created called attacked. Remember, we just created that in our top-down character. So as top-down character, we will call attacked. And then, once the attack executes, we will finish the execution of this particular task, and we'll call it successful. So we'll compile that and we'll save it. Now, if we go into our behaviors, we can actually just add this very simply. We're going to move our move to over, and our wait over. And remember, all this is once they sense a player and they react to the player, we're going to chase a player. When we get close enough to it that we're touching it, which would end the move to, then we will attack, wait 2 seconds, and then we can go on. So what we're going to do is we're going to drag this down. We're going to add our attack player task. And let's rename it to attack player. Okay, we'll save that. And now if we run it, he's following his patrol, we'll go over, we'll let him see us. He's going to come down and attack us, and we should flash. But we didn't flash. So let's go back and look and see what we missed. Okay, so we have the attack player task. And what we didn't do is we added our attack player task here, but our target player was still set to self actor, so we need to change that to player. So we'll save it again, go back in, play, get over here when he sees us and comes down to get us. There we go. You see we flash as he does the attack. He comes down, attacks us again, and so on, and yet if we get out of sight and such, he'll go back to his patrol behavior. So everything is what we expect. Now, if you want to do this for distance attacks, what you'd want to do is actually restructure this, because right now the attack player isn't going to trigger until the move to is completed. So what you're going to need to do is actually do some additional checks to see if you're within a certain distance, and if you are, then you would attack the player, and if not, then you would execute your move to. So there's some different logic you would do in there. And then depending upon the type of weapon, you might change distances. Therefore, your attack distance might change. You might actually call a function first to say, okay, we've seen the player. Let's call this attack function for our shooting weapons and see if we're in distance for any of our shooting weapons to actually work. And if not, then we're just going to skip the attack and go with move to a certain distance and then keep cycling around until we're actually in an attack range. If we're out of ammo, then we might go to keep moving until we can attack the player with a melee weapon. But as I said, I'll discuss that in much more detail in the advanced AI tutorial. So for our final behavior, we're going to briefly touch on running away. So you have an AI that's been damaged or is scared or is outclassed by another player or another AI instance, and so it decides that it just needs to run away. Not going to be a very detailed example because there are multiple ways that you might run away from something, but just to give you an idea of how you would set up such a behavior and how you might build a custom decorator and make it happen. Currently, we have an AI player who does his patrols, and if he spots you, he will come in and he will attack you. But what happens if he takes damage? What if he needs to run away for some reason? What if he becomes afraid? Let's take a second and let's explore this And let's see what we can set up. So for the first thing, let's create something that will actually give our AI character a reason to run away. Let's cause him some damage. And we're not going to do anything really elaborate. We're not going to create any apply damages or anything like that. We're not going to set up weapons. We're just going to create something that switches him to thinking he's been damaged. And so for that, we are going to want to create a new entry in our blackboard. So let's go open this up and go to our blackboard. And we will create a new key. And that new key in this case is going to be player afraid of. Reason being, the whole reason he's going to want to run away is he will have been hurt by a player and he wants to get away from it. So this player type will be an actor. And this will be the last player that hurt the AI. We'll save that. So that's pretty straightforward and easy. There's not a whole lot to that to worry about. And then we are going to go into our behavior tree. And we're going to want to add a new behavior here, a new sequence. Of course, if he certainly wants to run away, that's got to take priority over attacking at the moment. Although, you know, you can get into some real fuzzy logic situations based upon how hurt something is and how much damage they can do, etc. But we'll call this run away from player. It is that if he encounters a player that he's afraid of, that he's going to run away. We'll save that. Let's go to our human. We'll open up our top-down character. And we have our attacked behavior where we're reacting when he's attacked. But let's set up something to do some damage. And we're just going to bind H. So we put the hurt on. We put the hurt on the AI, and we're going to bind that to it. And what we're going to do is very simply put, oops. We're going to get all of our actors of class enemy AI. Of course, we only have one, so we're just going to grab the first one. But let's find our enemy human class there. And as I said, we're just going to get the first one because we know that we only have one player character. We're going to get the controller, or not player character, but one enemy AI at the moment. So we'll get the controller for that character. And then we are going to cast that to our human enemy AI controller, and that way we can access a function. And we're going to want to call a function on our enemy AI controller. And that controller function we're going to do, we're just going to call set damaged. So we have to go into our enemies for a moment and find our enemy human AI controller. We're going to add a new event so we can get over here and out of the way. And we're going to call this set damaged. And it's going to have one input, and that input is going to be the player that damaged it. So damaged by, and this will be an actor. Whoop, not a sensed actor, but an actor. Okay. Now what we're going to do is go back over here for a minute, and in our top-down character we'll finish setting that up. So set, whoops, yeah, set damage, that was right the first time. And And so the target will be the AI controller. And then damaged by, we're just going to grab a reference to ourselves. So our player character. We can compile that and save that. And now in the AI controller, what we're going to do is really very simple. We are going to get the Blackboard object. We're going to do a set value as object, where the value we're going to set is going to be that afraid of that we set up, and we're going to put into it the player that damaged the character. So we'll make a literal name here. We'll call this player afraid of. Whoops, got a case issue there. Okay, I don't get why I keep capitalizing that. There we go. I don't know why it's doing that. Let's go back over here for a second. Look at our Blackboard. Nope, it is the right size there. So I don't know why it keeps doing that here. That might fail. We'll find out. And so we set the value as object, and just so we can see that we actually made our damage, we're going to print a string. And the string is just going to be simply damaged enemy. Okay. And we compile. Now that's successful. And let's just run this quick, make certain that that's going to work. Our enemy is having an issue at the moment. But if we press H, we see that we damaged the enemy, so it is calling the function here. And theoretically it is setting that Blackboard object. So the next thing we want to do is in our behavior tree, we need to finish fleshing this out. So what's going to happen when we run away from the player? So the first thing we're going to want to do is build a custom decorator. And the reason being that we could say, for instance, okay, if we've been damaged, we're just going to set this, then we'll have a runaway behavior. But right now, our only real basis for setting it is on the fact that we will have set who did the damage. But just because they're damaged, we don't want them constantly running away, especially if the player is nowhere around to actually hurt them. So what we're going to do is we're going to build a custom decorator that just checks to see if the player that they're afraid of is anywhere around. So to do that, we are going to create a new decorator. As before, we'll save this. We'll go out to our example map. We're going to rename it. And we're going to call this damaged by player near decorator. That way we know it's a decorator as opposed to a task. And then we open this up, and we'll have to go back to a full blueprint. And unlike when we set up our task, what we have to do when we are setting up a function is we're going to go up here to an override, and we're going to override the function perform condition check. And here's where we set up the logic for this. And so what we're going to do is we want to add a variable, and that variable is going to be player damaged by, which, as you can read, is the player that damaged this particular character. And this is an actor. Actually, no, not an actor. I'm not thinking about that correctly. I almost put that down. This is a Blackboard selector key. And what we're going to do is drag that out because we'll set this when we set up our decorator on the sequence. But we're going to get the actor. So get the blackboard value of the actor. Of course, this is going to be polling the entire time, so we need to make certain it's valid, otherwise it's going to give us a bunch of errors. So we'll do an isValid check. Okay. Okay. So if this is valid, then what we're going to want to do next is get a reference to our AI, which is what is an owner actor here. And we're going to cast that to our enemy human AI. Put that up there. Just try and keep this neat, so we'll pull that down just a little. This down a little. Okay. We can slide that over. So what we're going to do is get the pawn we're controlling here. And once we have that, we will get its location. And now if we get our returned actor here, we take their location, and vector minus vector, we'll take the vector length of that, then we want to check and see if that's below a certain length. And so we'll say if that's below, will be arbitrary 1,000, so 1,000 units, then the person they're afraid of is close enough to make them want to run away. So we'll connect that up there. There you go, and again we'll walk through that really quick. So if the player that has damaged them is set, which we'll know because the isValid will be valid, then we are going to cast our AI to the enemy AI controller. We're going to get whatever pawn they're controlling, the location of that pawn. We're going to subtract our player's location, or the location of the player that damaged them, from the AI pawn's location. And if the length of that is less than 1,000, meaning they're pretty close, then we will have them return true. Now we will know that it's close and it should behave on it. So we'll take that, and we can go into our enemy human behaviors. We'll add this as a decorator. So damaged by player near decorator. And of course we have to give him something to do to run away. Now, there are lots of ways you could do this. You could set up different navigation points and just have it choose a particular navigation point to run away from. You can randomly have them run in a direction, which is kind of the approach we're going to do. You could, if you were using the environment query system, which we'll talk about in the advanced tutorial, you could use the environment query system to find an ideal place to run away to that's the right distance, that has the right properties for hiding, so it's got the right height and everything else. But again, for this instance, we are just going to go with something simple. We're just going to have them run away randomly. And to do that, we're going to create another custom task. Oops, have to make the task first. That would help. Okay, once again, we'll save, close that, go out. Whoops. This will be our runaway task. This will be run away. We'll go into our full blueprint editor here. And now what we're going to do is we are going to start our receive execute, just like we did with the attack. We have our AI controller, so we're going to have to cast that. Oops. So we now have that cast because, once again, we're going to want to get the pawn because we're going to affect the pawn's location. So we have the pawn. And we're going to need to get the player that we're running away from. So let's add a variable for that. So player to run from, which of course will be another selector key. I want to make that editable. Okay. And we're going to drag that down. And we're going to get that blackboard as actor again, just like we did when we were checking for the distance. And we'll get their location. Of course, we want to run a direction different from where they are. And so what we're going to do is we are going to break the vector for their location. And we are going to want to add a distance to it. So we'll do a float and float. And we'll just say a random float in range, anywhere from 500 units to 1500 units. So it might run a short distance, it might run a long ways away. Now we're going to make a new vector out of that. I'm going to pull this across and AI move to, because we're going to make our wonderful AI pawn move to the location that we've just set up in our return value here. And then at the end of that, of course, we want to finish our execute. Okay. Now there might be other things you do here. We're going to mark it as successful, but you might want to check that and, you know, do booleans for that or other stuff. We're just going to leave it like that. We'll compile and save that. Now, if we go back into our enemy human behaviors, we can actually add that as a task. So runaway task. And then for both of these, starting with the decorator, we need to make certain our player is damaged by the player afraid of. We're of course going to abort anything that is a lower priority, which will be the attacks and everything to the right of it. And then we are going to run away from the player that we're afraid of. So let's just go and see if what we set up works. Okay, so it's off and running. It's doing its normal patrol. Oh, we've now told it we've damaged it. So we get close, and it's trying to run away. Of course, if we move far enough away, it's going to go back to its patrolling behavior. If we come up, then once again, it's going to try and run away from us. We move away, and it goes back to its patrolling behavior. Go towards it, it runs away again. So that's the basics of setting up a running away behavior. And again, you might want to set up other things here. You might want to make this more complex. And because you can create a custom decorator, you might have lots of things. You might say, okay, the person damaged me, but they have under a third of their total health. Therefore, I'm going to attack them anyway. Because they may have damaged me, but may have only lost 1 health. You can put all sorts of things into this custom logic, or you could create multiple separate decorators and use a composite decorator here that would do different things. So really quick, I'll just show you. So let's say, for instance, you had actually, I didn't want to go back into that one. I'm just going to remove that for just a second. If we said we want a decorator that was a composite. You double click on that, you start dragging in other decorators. So we can say, okay, what is the result of our damage by player? Player afraid of, still aboard slower priorities. We could put that there. But more likely when you're doing a composite, you would have something like an and or an or whatever else. So you might say, okay, if they're damaged and I'm not certain what else to throw in here as an idea, but okay, so you might say, are they near, and am I in a place I could run? Am I in a location that is close to a patrol point or something? And if these are both true, then you'll actually get a true result, and it will continue to execute, or it will take priority to execute and cancel like it should. But in this case, we're not actually going to do that. We're just going to stick with the custom decorator that we made. Whoops, wrong one. There we go. And we have to make certain again that that is set to our player that we're afraid of, and we're reporting anything with a lower priority. So just one more time, we'll go out there and make certain that I didn't screw anything up when I did that. There, we damaged the enemy. Go up there, and the enemy runs away. We go down, the enemy goes back onto its thing, but hey, we're a little too close. So he's going to try and run away. Okay. Next, let's talk about how we expand our artificial intelligence's senses to do more than just seeing. In this example, we're going to add hearing to our AI, and you'll see kind of how that can be applied to other things as well. Within our AI perception that we added to our AI controller here, you have the ability to add other senses. So right now, we currently have AI sight configured. That's our dominant sense. But we can also add other ones. So if we wanted to, we could add a damage sense. If it gets damaged, it reacts to it. Hearing, prediction, team sense, and so on. We'll cover team sense and prediction, and maybe the others in the advanced AI tutorial when that is recorded. But for now, we're just going to look at the hearing configuration. And so very simply, we're actually going to leave it alone. We're not going to change anything about it. We're going to start it enabled. We're going to leave it at its large range for the sake of our demonstration. So nothing really fancy there. We're going to compile that and save it. Now there are things we have to do. So for instance, we have to generate noise for it to actually hear noise. And what we're going to do is we are going to need to generate a noise event. And we can have our top-down character do that. So much as we hit H to do this, we're going to add an N. So we can make a noise event. And your noise event in your game could be related to footsteps. You could have it tied to your weapons firing. You can minimize noise based upon stealth. Any number of things. Again, this is just to give you an idea of how the hearing perception works. So we'll set this up here, and we are going to use a function called report noise event. Just to show you that you have damage events, noise events, and perception events. We're just worrying about the noise event right now. And when we're done plugging everything in, we're going to do our favorite thing, print string. So we can say, made a noise. Now as for the parameters for our report noise event, I think I need more room here, so we're going to slide this up even further. What we are going to do is we are going to get our human player's location, or our player's location. So we'll just get the location for ourselves. And We're going to reference to ourselves as the instigator. And then we will set our loudness can just stay as it is. Our max range, we're not going to worry about because we're just going to let it pick up anything. And we don't have to tag it. So we can compile that. And of course, if we play, we can make a noise, but nothing's going to happen, even though it's got the sense. It doesn't know how to react to a noise yet. So if we go to our blackboard, so let's first go to our behavior tree, and then we'll click over to the blackboard. We're going to add a new key, which is a vector, noise heard at location. Because it's going to respond to the location where it heard the noise. It's not necessarily going to know who made the noise, but it's going to go check out where the noise happened. We'll go back to our behavior tree here. And we're going to want to stick this in under our patrol, or not under our patrol, but to the left of our patrol, because in order of importance, if they're damaged, they want to run away. That's going to be the most important thing. If they see the player, they're going to want to chase the player to attack the player. That would be second important. If they hear a noise, they're going to go look at the noise. I mean, if they were reacting to hearing a noise and then they saw the player, that should cause them to want to chase the player instead of going after the noise. So what we'll do is we will create another sequence. And we will call this sequence react to noise. Okay. And what we're going to do when we react to a noise is we're going to move to the location where we heard the noise. So the key we're going to look at is the noise heard at location. We're going to move there. And then once we get there, we are going to wait for 2 seconds. Of course, this can be overridden as well. We'll have it set up to where if it sees the player while it's waiting, of course it's going to turn around and go after the player. We'll save that. One thing we're going to change here is our move to location acceptable radius for getting in range of that location will be a 50 to be satisfactory. And of course, once again, we have to have something up here for it to react to. And we could say, is the noise location set, except that there's no way to really turn a vector into a null for it to not have a set noise anymore, not have a set location. So once again, we're going to have to create a custom decorator. Okay, so we'll save this, close it out, go back and rename it. And this is going to be our location not default decorator. And the reason why I'm calling it that, now we'll forgive the capitalization error. The reason I'm calling it that is because, again, since you can't null out a vector, it's just got a default location of 0, 0, 0 at a minimum. If the location is set to hear a noise and it's not 0, 0, 0, then we're going to want to have the AI react to it because then it has heard a noise. Otherwise, if it is set to 0, 0, 0, it's going to ignore it. It's going to pretend that that location hasn't been set. So let's look at what it takes to build this custom decorator here. Open our full blueprint editor. And once again, we are overriding, so we have to override our perform condition check. There's going to be a lot of stuff in this one, so we're going to go ahead and break that link at the moment. I might actually pull this over a little bit, just to give us a little more room. Okay, so we need to get our AI controller again, because we're going to want to get the location. So we do that, and then we get our controlled pawn. And from there, we get the location of the pawn. And I'll walk through all this to explain the whole logic once it's built here. we are going to want to have a variable called location, which is going to be the location where we heard the noise. And again, that's a blackboard select key selector. So we can pull that down. And we're going to want to get that blackboard key as a vector because we need the location. Then we're actually going to do a couple checks while we're at it. I'm going to slide this over a little more. The first is that we want to make certain that this is not equal to 0, 0, 0 already. Because if it is, then there's not really a point to moving on with this. And just because if it's close enough to the location where we're going to go ahead and stop anyway, we will do a subtraction of the vector of the pawn and the vector where the noise was heard. And then we'll get the length of that. And if the return value of that is greater than or equal to 50, which is what we set our acceptable radius to be as well, if both those things are true, that the pawn is still at least 51 or more units away from the location where I heard the noise and the location hasn't changed to 0, 0, 0, then we're going to go ahead and return true. But the other thing that we want to do here is the hearing thing isn't very smart. I'll walk you through it. When we get down here, it doesn't really have anything that resets it. It can get to the location, but then it sits there and triggers back to react to noise because it doesn't really have it emptied out, and so it never really escapes this function to move on. And so what we're going to do is we're going to do a branch. So we can reset it in here. So we'll go ahead and pull this over. And so what's going to happen is, assuming that this is true, it is farther than 50 units away and it's not 0, meaning it's still moving to the location where it heard the noise, then we're going to return our true. And if it's false, then we are going to reset the value of the vector for the location key to be the default of 0, 0, 0, 0, 0. And then we can plug that up there. So again, I just want to walk through this one more time. We get our location of the pawn that our enemy is controlling. We're going to subtract from that the location where the noise was heard, and if it's less than 50 units away, we'll basically stop. If it is more than 50 units away and the vector has not been returned to default, then it's going to return true, so it's going to keep performing whatever's in that branch. So if either one of these is false, if it's been set to 0 or we're less than 50 units away, it's going to zero out the vector back to its default value, which will make this stop running. So we can do that. We can go back over here, and we need to add that decorator to our react to noise. So location not default decorator. And it will abort anything of a lower priority, so if it hears a noise, then it's not going to continue patrolling. And that should be it. I want to make sure I got everything saved here. And let's play and let's see what happens. Well, first off, we might have an issue because he's not patrolling. Let's see what happens. Yep, we make a noise and nothing happens. So we have an issue that we have to look at. And let's see what's going on here. So, first thing is, it's not actually. Let's open this back up. We have our location variable, but we didn't make our location variable editable. So if we go back into our behavior tree now, we click on this, noise, heard a location, aborts lower priority, and it keeps going. So now if we save that and we play, we still make a noise and it's not moving. Debugging behavior trees can be a lot of fun. Not always, but sometimes. Okay, so we've got that. Our noise heard a location. Just shrink that a little bit, make it a little easier to read. Let's see here. Aborts lower priority. React to noise sequence. And that's what it's aborting as lower priority. If we do the move to 50, noise heard location. Noise heard at location. Noise heard at location. Let's look at something here for a second. Noise heard at location. Where's our top-down character? It's reported the noise event. That should be just fine. We don't need the damaged thing anymore. We don't need damaged our player open at the moment. Our runaway task, that's from being damaged. We don't need that. Let me look here and make certain I didn't screw up the check for this. So we perform our condition check. Again, we've made that editable. To location blackboard tree. We cast it to our human AI controller, our pawn, we get the location, we get the key, we're not equal to the default, and we're more than 50 units away. So that should be returning true. Okay. So let's see here for a second. Let's just break that link for a moment. Save. Now if we play, he's running. Oh, I know what's going on. Okay. So, Vector, it picks up on random noises. Don't ask me why. It seems to be an issue with the AI perception that it picks up on random noise. And so it's not going to do anything. But the other thing is that we haven't altered the AI perception event. Kind of important to do that. So if we go into our AI controller, which I accidentally closed, and we go to AI perception here, and we go into our on perception updated, we actually have to make a change here. And what you're going to find, and this is very, very, very frustrating, is that the perception system doesn't work very well yet for some of the extended perceptions, at least not that I can get out of it. So, for instance, there is a function, get sense class for stimulus, and if you were to take the stimuli that we pulled out here and plug into there and keep going, you are supposed to be able to get the sense class, so you'd get back, for instance, the AI hearing or AI sight or whatever, and you'd be able to tell. I don't know if it's something that's missing from my particular implementation or if something got bugged, but it doesn't return anything for me. So it becomes kind of worthless for me. Otherwise, we could base off of this and take action around it to say, okay, if we're hearing something, do this. If it's sight, do this, and so on. But here's the workaround that I found, which is you can always get all the perceived actors of a certain thing. Now, hearing, once it's there, as I said, it always seems to pick up weird hearing things unless you zero it out. So what's going to happen is if we're picking up something and it's sight-based, we're going to come over and set our player that we've seen, and that has the priority anyway. If it's not, but it still picks up something with a sense, we're going to set it in the false. So it's not successfully senses a sight thing, but it will show up in the list of perceived actors for hearing. And like I said, this is kind of a hack workaround, and really in the pawn sensing component, the hearing so far worked a lot better for detecting noise and generating noise and so on. And the reason why I didn't just go back and show you that is because, just like I said when we were doing the sight AI to increase functionality, the pawn sensing is being deprecated and is going to be phased out. So I didn't really want to focus on something that's going away. Show you what you can do with the current one with AI perception. And if any of you out there watching know what the issue is, why I can't use the sense class function, or you can think of a better way to do this, I am open to hearing it and updating the tutorial to account for it, to make it better for everyone. But this is the workaround that I have figured out for now. So what we have to do is we have to grab a reference to our AR perception component. We are going to get perceived actors. What we're going to get for our perceived actors is anyone who was perceived through hearing. And I hate to break away for a second, but this makes me think of something, which is in our AI perception here, just like with sight, we want to make certain that enemies, neutrals, and friendlies is detected. Because in blueprints that doesn't work quite right yet. So we get our perceived actors. We are going to want the length of this, because in theory there's a chance we couldn't get perceived actors back through hearing, but again, it seems to be slightly broken. I get one back even when there's not noise being generated. So if it's greater than 1, then we're going to go ahead and go to this section of functionality. What happens is we will get the first record, because we should only be getting one since there's only one player at the moment. Otherwise you would have to loop through these. And from that we are going to get the location. Oops, get actor location. And then we're going to set our blackboard. So set value as vector. And so we're going to set the vector value there. We need to make a literal name for this again, which will be noise heard at location. That is what we called in the blackboard, right? Noise heard at location, yes. We'll plug that into the key name, and then we just need to get the Blackboard object. Okay. So we have all that in place. If we hit play, and he's still not running around. But if we make the noise, then he comes after us. And then of course he waits, nothing happens, he runs back. If we were to make a noise, and he were to come over and see us, well, then, in theory, he should be trying to chase us around. Like that. Now, here's the thing. You're wondering why he's not taking off right here. Well, if we go into debug mode, you can see that this flips back and forth. And the reason why it flips back and forth, you can see it's reacting to noise, going to patrol, reacting to noise, going to patrol. It's picking up that random noise, even though nothing was set. And so what we need to do is we go into the begin play for our AI controller. And after we start running the behavior tree, we need to set value as object again, or as vector again, and set a default value. So we'll get the Blackboard and plug that in. Make literal name, which will be noise heard at location. This will zero it out. We compile, we save, we play. You'll notice he's now taking off and running because he's not being confused by false noise. Now if we hit the noise, he comes to check it out. Then he turns around and goes back after a couple seconds. None of our other behavior is affected. You know, if he sees us, he's still going to try and chase us. If we put the herd on, he's still going to run away. When he gets far enough away, he breaks his pattern. We can still get him to come back over and check stuff out. Right? Once he'll come over, he'll go back again, and all those behaviors still work. So there you have it. That's an interpretation of hearing. And again, this is kind of a hack way to approach it. If someone has figured out a good way to do it, please let me know. I can tell you that it's a lot easier to implement this, relatively speaking, if you are working in C++, because all these different things, including, you know, the enemies, neutral, and friendlies, and all that all works in C++. So it's a lot easier to deal with. Hopefully blueprints will catch up soon. It would be horrible if they deprecated the pawn sensing component before all that was working very well. But there's a couple other things we can do really quick if we want to. You can always go in here and you could tweak some of this. For instance, when you're going to chase the character and attack the character, you wouldn't necessarily have to wait if you didn't want to, but you can. For the patrol point right now, we just keep moving through them. You could always have a stop and wait at the patrol point. You could have it to where, you know, as soon as he arrives at the location, he doesn't have to wait. There are just little tweaks that you can do here if you want to improve things. But for our purposes, I think he's working pretty well at the moment. So let's talk for a second about how you might make better decisions with your AI. We've touched on some real basic behaviors, real basic approaches to implementing them. But AIs can and often do get much more complex than we have them here by far. And so there are different things you might do to help your AI make better decisions. So for instance, you can have multiple blackboards and multiple behavior trees. I mean, we've got a one-to-one association here, which is how it usually works between a behavior tree and a blackboard. But again, you can have multiples. And what you can actually do is, let's say that you have a behavior here. Let's say after you hear a noise, you want to take a different set of actions further down. You can actually pull off another task, and that is to run a behavior. and it actually runs an entirely different behavior tree that you give it. So you click up here, you would choose the different behavior tree. Of course, we only have one at the moment, but you would choose a different behavior tree and it would automatically start running that. You can also add different ways of doing things. We've done pretty much all sequences with the exception of our prime selector here. We have simple parallel where you can run things in parallel and it does checks upon both. Of course, you've got additional tasks that we haven't looked at in the blackboards here. Our custom ones that we made. You can have the AIs make noise. You can have the AI play different animations, so attacking animations and such. You can play sounds. You can do all sorts of different things. You can rotate the face, whatever the blackboard entry is. So you can have your AI rotate to face the player who is attacking them or something. You can do all sorts of stuff through that, through the tasks that are already built. Of course, you can build your own tasks. You can call out to functions that are within your character with tasks, or within weapons you might build, all sorts of things. For better decisions, we talked about the fear factor over here. You wouldn't necessarily just say, hey, someone damaged me, I'm always going to run away. You would want to build more sophisticated logic to take into account all the conditions around the interaction between the AI and that player. So, again, if the AI has taken 1 point of damage, it probably isn't going to worry too much about running away. If it's got strong weapons, it may not worry about running away. It may just be the type of character that, maybe let's say there's 10 of them, and it knows there's 10 of them, so it knows it's got strength in the number, so it doesn't run away. But if it's alone, then it does. Different things that you can put in for logic. And you can actually add multiple decorators. So you can try it if you want. I generally would lean towards the composite and have different logic there, but you can do it. The other thing you can do is you can build a service, which is something we'll talk about in the advanced tutorial. I build out a service to do some of this, and that uses more complex logic as well. But the point being, don't be afraid to work with different ways of making your AI more intelligent. It's not really all that hard. You just have to have a clear idea of what it is your intelligence is going to react to and what actions it wants to take, and then work out the logic from there. Let's touch really briefly on group behaviors. I'm not actually going to show a demo. I'm just going to talk about some of the things you can do. Group behaviors are going to come in a separate tutorial. So the next tutorial I'm going to record is going to be the advanced AI tutorial, and then there's going to be a separate one beyond that, which is all about group behaviors. In group behaviors, things are defined generally in two categories. There are flocking behaviors, which are kind of like they sound. Think of a flock of birds and how they travel. And then crowd behaviors. In a crowd, everything just kind of moves according to the whims of whatever the character's AI should be. So, people walking down a street are going to behave one way. People crossing the street are going to behave another. How they interact doesn't necessarily have any interactor consistency to it. A flock, on the other hand, is going to move very much like a flock of birds does, where they have a certain formation, they tend to keep a certain distance from each other, there is generally a leader involved, all of that. And so, from a behavior tree standpoint, you might add additional behaviors that are related to sensing and reacting to things like the distance of the other AI characters around you. Within your enemy character itself, let's pull up the enemy human character, you might actually do something like adding another component. So let's say, for instance, a sphere collision component that you would make large enough to detect if there was anything else colliding with it that was another AI character, and therefore would always try and maintain just the right distance to keep this sphere empty while still pursuing a certain direction and logic. That's an example. you would want to potentially have one AI that has a tag or a variable or a component. Maybe it'll create a custom component which is for leadership. So the other AIs that are within a certain vicinity around it move the same direction as that leader does. If that leader gets killed, maybe the second one picks up, or the one closest to the target or something picks up and becomes the leader, and the flock reshuffles itself. There are just a lot of different things that go into group AI, and again, I encourage experimentation because once you start playing with it, I don't think it's that hard to do. Certainly not flocking behaviors. Crowds can be a bit more difficult because they're more random and dynamic, but flocks, you're generally going to, again, focus on keeping a certain amount of space between all the characters in the flock, keeping them moving in the same direction. If they have to turning to match the rest of the flock and so on as they head towards their target. Navigation and pathfinding. You build, for instance, like your sphere here. If moving around a target is going to bring them closer into the sphere, they might lag behind for a little bit and then speed back up to try and catch up with the flock. Just different things to experiment with. And again, there's going to be an AI tutorial specific on flocks and crowds, and that will probably come out. Let's see, I'm recording this in March. That will probably come out in May, because the advanced AI will come out in April, and then May will be the group. So, just to give you some thought, get that going, see what you think. And so that wraps it up for the basic AI tutorial. I hope you found it useful. If you want some more information on mindless pursuits, you can look at these links. If you have any questions, please feel free to post them. If you like the video, I would really appreciate it if you would click that like button and share this information with others. If you have not considered subscribing, please consider subscribing. And as always, I want to thank everyone watching for all of your interest and support. Now get on out there and make some decent games. Have fun. Bye-bye.